Okay, we're going to start chapter 1. I want everybody to understand that this lesson is going to feel a little bit vague until we've practiced it a little bit more throughout the course. You might not totally grasp the domain, range, codomain, one-to-one, and on to today. I think we can master continuous and discrete today. When you leave, I expect you to understand what those two mean. I believe we could understand the interval in the set builder notation. I think we can grasp those pretty well, how to write them. Now, identifying the domain and the range, that might take a little bit of time. So all that I'm asking is that you show yourselves a little bit of grace as you're trying to decide if you understand this lesson or not. Be patient with yourself in grasping the concepts. Okay, so we're going to teach it so that as we're moving through the course and I refer to it again, I have to teach it to you at some point. So you're going to, one of these days it'll click. So let's get started. The vocabulary of it. Okay, first we have the domain. The domain is any x value in the function. So for instance, let's say this was my graph. It starts right here and it's going to go that direction. Okay, so if this was my graph, the domain of this graph, the x values that it could be, it starts at 2 and it goes to the left. So as we go to the, it goes to the right, not the left, it goes to the right. As we go to the right, x gets bigger. So the domain of this function, I need to zoom out just a little bit. The domain of this function would be x is greater than or equal to 2 because it starts at 2 and then it gets bigger. Okay, so that's the domain. The other main one of these that we're going to deal with is the range. I'm going to skip that second one for just a minute. I'll come back to it. The set of all the y values that actually result from the evaluation of the function is the range. The range of this, range is the y values. So starting here at 1, and then the graph is going up. So again, y gets bigger as we go up. So the range of this one would be y is greater than or equal to 1. Okay, so that's where we get our domain and our range from. The codomain. That is the second blank that I skipped, the codomain. The codomain will be assumed to be all real numbers unless it's otherwise stated. If they could state it to be anything else that they want it to be. And we're going to use the codomain with the range when we determine if it's an onto function or not. Okay, so the next blank is 1 to 1. 1 to 1. 1 to 1 means each element of the function's range is paired exactly with one element of the domain. Okay, so let's simplify those words. That's a lot of words. Let's simplify those words for just a minute. Basically, no y can be repeated. No repeated y value. There's no repeated y value. This is also when we will use the horizontal line test if we have a graph to look at. So that is the horizontal line test. Horizontal line test. And that just means that if you were to put a horizontal line across the graph, it can't touch at 2 places at the same time. It can only touch at 1 place at the same time. Okay, and the very last vocabulary word blank that we're going to fill in is onto. A graph or function is considered onto if the codomain is the same as the range. There's one more thing that we need to discuss front load in the lesson before we get going, and that is the vertical line test. It's considered to be a prerequisite skill, but teaching it to other classes today, I learned that not everybody remembers the vertical line test. The vertical line test, what it tells us is if it is a function or not. Let's see, is it a function? We'll just do that. Is it a function or not? Okay, so how the vertical line test works. Let's say we have this parabola here. We make a vertical line on it and imagine that vertical line moving left and right. It's only going to touch this parabola at one spot at a time. So this one is, yes, it is a function. If that parabola was laid over on its side and you did a vertical line test on it, it's going to cross that graph at 2 points. So this one would be no, it is not a function. Okay, so the horizontal line test is going to tell us if it's 1-to-1. The vertical line test is going to tell us if it is a function or not. Okay, pause it if you need to finish writing all that down. I'm going to move on to example 1. Example 1, looking at the same parabola, we're going to find the domain, the range, and the codomain. The domain, what's possible for the x values? It looks like is constrained. Hold up. Just changed my microphone and I don't know if it's going to record my voice. Just a minute. Okay, we're back. I just wanted to make sure that my voice is being recorded. Okay, the domain. It looks like it's restricted between -3 and 3. But if you notice these arrows on the end, that's going to keep going. So this isn't stopping right there. This is going to keep going past that. It keeps going on forever. So it's going to go past -3 and 3. It's actually going to be all real numbers. It will end up being all real numbers. Another way to write all real numbers is with an R with 2 lines on the back of it. That is how they denote all real numbers in math class. Okay, the range. The graph here is never going to go above 0. It's a parabola and it turned right there. So it's not going to ever come back up here to the positive numbers. So the range is y is less than or equal to 0. It starts at 0 and then it's everything down from there. The graph goes down. The codomain, because they didn't state it otherwise, I told you if they don't state it otherwise, it's always going to be all real numbers, or use that R again. Now, if we did a horizontal line test on these, would it be, we do a horizontal line test, would it be a 1-to-1 function? It touches twice. So no, it is not 1-to-1. Is it onto? Onto, to be onto, these have to be the same. So since those are different, the range and the codomain are different, those are not onto. So since those are not the same, it is not onto. To be onto, they'd have to be the same. Okay, we're going to practice this skill one more time here in the next question. Looking at this, trying to decide if it's 1-to-1 or onto. Now, it's not going to be 1-to-1. It's going to fail a horizontal line test. So it's not 1-to-1. Okay, but is it onto? It doesn't say otherwise. So currently, the codomain would be all real numbers. The range of this is up 3. So the range is y is less than or equal to 3. Now, the reason why it's less than is everything below that line, everything below y equals 3. So it's the range is y is less than or equal to 3, but that's not the same as the codomain. So the range is not the same as the codomain because it does not include the numbers that are greater than 3. I'm just going to write greater than 3. The real numbers that are greater than 3 are not included. Therefore, the function is not onto. It says for what codomain is f of x an onto function? This was actually an ACT question, a retired ACT question. Kind of confusing because what is a codomain and what is onto? Well, that's what we're learning about today. And for a function to be an onto function, the codomain has to be the same as the range. Well, the range is y is less than or equal to 3. So to make this function be an onto function, the codomain has to be stated as y is less than or equal to 3. Okay, so really what this question is asking you is what is the range? And just make it a little more difficult than that. Okay, from a table. From a table, it says to look at the table, look at the number of gold medals in these 5 years, and then the number of silver medals, and decide if it is 1-to-1, onto, both, or neither. Now, to look at a table, remember to tell if it's 1-to-1, you're checking to see if there are repeated y values. So when I look at the gold medals, I'm going to let x be the years and y be the number of medals. Well, if this is my y values, 46 was repeated, and so was 36. 36 was also repeated. Okay, and that's what it explains over here with all these words. It says, let f of x be the function that gives the number of gold medals won in a particular year. The domain is in the column year, and the range is in the column number of gold medals. The function is or is not. It is not 1-to-1 because there are repeated y values. So it is not 1-to-1. There's repeated y values, so it is not 1-to-1. It repeated in 2016, was repeated in 2012. They were both 46, and 2008, 2004, they were both 36. They are also not onto because the range does not include every whole number. The range would be these values right here. It does not include every whole number. It only includes 36, 37, and 46. So it is not onto. The silver medals will not be onto either, but will it be 1-to-1? Check and see, are there any repeated y values? The silver medals will be our y. There is no repeated values. So this one is yes, it is 1-to-1. Oh, you can't see what I was writing. My bad. It is 1-to-1. The function is 1-to-1 because no value in the domain shares a value in the range. The range, there's only one of each one. Okay. Instead of a table, what if we look at a graph? Well, to check and see if it's 1-to-1 on a graph, we're going to use a horizontal line test. We're going to do a horizontal line test to check and see if it's 1-to-1. So let's do that first. Let's look at all 3 of these, make a horizontal line on them. Will it cross at 2 places at the same time? It's not going to. It's only going to cross 1 time at each place along here. So this one is 1-to-1. Look at the next one. If you make a horizontal line, it's going to touch at 2 places. So this one is not 1-to-1. It has 2 different x values that share the same y value. The domain shares 2 of the same ranges, so it is not 1-to-1. This one, make a horizontal line. It's good to go. It only touches at 1 place, so it is 1-to-1. Okay, so let's talk about onto. Remember, onto means that the range and the codomain are the same. The codomain is not stated on any of these, so it's assumed that it's all real numbers. This graph never goes below 0. All this stuff, it never goes down there. So this one is not onto because the range is y is greater than or equal to 0, not all real numbers. This one, it never goes up in this area. So the codomain is all real numbers. The range stops at 3. I think it's 3. Yeah, it's 3. So this one is not onto. The codomain and the range are equal to the function, so are equal. So the function is onto on this one. It goes up and down forever, so that's all real numbers. The codomain is all real numbers if not otherwise stated. So this one was neither. This one was both. And this one was only 1 to 1. Okay, so I want you to try the next 3. Look at example 3. I'm going to pause it, and then I'll reveal my answers in just a moment. I really hope the recording did not just mess up again. It just glitched on my end. Please let it all be okay. And then my microphone be working. Let me make sure I'm not muted. Oh no. Time out. Okay, we're good. Maybe. Hopefully everything's working still. I'm gonna keep going. All right. This one. Horizontal line test, it fails. It's not 1 to 1. Is it onto? Assume they're all real numbers for the codomain. The range would not include anything down here. So it is not onto, so it is neither. The next one, 1 to 1, horizontal line test is good. You could slide a horizontal line up and down this. It's only going to cross at one point at a time. Onto, it goes all the way down. It goes all the way up. That's all real numbers. Says codomain is all real numbers. So this one would be both. Did we get it? Let's keep going. This one, horizontal line test is fine. Horizontal line test is fine. So this one is 1 to 1. Is it onto? Well, it never comes up here. It's not going positive. So it's not onto because it's not all real numbers like it says down here. So this one is just 1 to 1. And then this one, horizontal line test, it fails. Oh, it has to be onto. How is it onto though? Because it doesn't come down here. Well, It says that the codomain is y is greater than or equal to 1. So because it's stated otherwise, and that matches with what the range is, this one is on 2. I kind of scribbled over that. Let me rewrite it. That one is on 2. Okay, how do we do? Kind of hard, isn't it? Okay, but this next part, I feel like we should all be able to understand. So get your thinking caps on. The 1-to-1 onto domain range, we will work with that enough that you'll get the hang of it eventually. Discrete and continuous functions. A continuous function is a graph that's going to just keep going. There's no breaks in it. Okay, if you're talking about a continuous event like time usually is connected because the events continue across time. But there might be situations where there's a break in it. A function that is not continuous is a discontinuous function. And a specific kind of discontinuous function, which the points are not connected at all. For instance, if we were going to graph the size of shoes of all the students, we wouldn't connect that. Those events aren't connected. They're separate people with separate feet. So it is a discrete function. So a continuous function is one that just keeps going, no breaks in it. A discontinuous function may be continuous for a point, but then it breaks and then it goes again. A discrete function is all little separate events. So it looks like polka dots on the graph. So when we look at A, B, and C, I think C is really easy to identify. That's discrete. Look at it. It's got polka dots. That's discrete. A bunch of individual events is a discrete function. Look closely at B, you're going to see a little break in it. Okay, but it's continuous. There's stuff that's connected. There's just one little point where it splits. So our options, it would be discontinuous, but our options are discrete, continuous, or neither. So this one is neither. And this one is continuous. It doesn't ever stop. It just keeps going. The turns don't matter. That's not what we're talking about. We're talking about whether there's breaks in it, whether you'd have to pick your pencil up to keep drawing it. Okay, so this graph here, at a quick glance, you look and you're like, oh, well, there's a break in it. It's not continuous, but that break is supposed to be the origin. And if you zoom in closer, you can see that the line does not break there. It keeps going. So that is supposed to be an O for origin, not a break in the graph. So the function is continuous. And then the domain, remember, we just talked about this. The domain is the X values. The range is the Y values. So the X values could be anything. It's going to the left, it's going to the right. Drag that down there. That's the domain. It's all real numbers. The range starts down here at -3 and it goes up from there. So Y is greater than or equal to -3 is the range. That's as far as I got for day 1 with the classes today in class. But I had to re-record later because the sound wasn't working. Hopefully we haven't had any more issues and it works this time. But I'm gonna go on and finish this lesson. So it says determine whether the function that models the cost of coffee beans is discrete, continuous, or neither discrete nor continuous, then state the domain and the range of the function. Okay, because customers can purchase any amount of coffee up to 2 pounds, the function is continuous over the interval from 0 is less than or equal to X, which is less than or equal to, and you would put the very top value on that, which says 35. Oh, no, how many pounds? How many pounds could they purchase? That's the X's. The X's is the weight, and they could purchase 5 pounds. For larger quantities, the coffee is sold by distinct amounts. That part of the function is I think they want us to say domain there. Let me double check. I don't want to plug in the wrong thing and confuse you later on. Oh, I filled in this blank wrong. It says, I didn't read it carefully enough because customers can purchase any amount of coffee up to 2 pounds. The function is continuous over the interval from 0 to 2. Then it breaks. For larger quantities of coffee is sold by distinct amounts. This part of the function is discrete. They're not connected because it's not an interval and spread out. That one is discrete. Since the domain and range are made up of neither a single interval nor individual parts, the function is neither discrete nor continuous. It is just discontinuous. I'm just going to put neither. It's that one, the neither discrete nor continuous. The domain of the function is from 0 to 2 or x equals 2.5. What's the other ones? 2.5, 3, and 5. This represents the possible weights of coffee beans that customers could purchase. The range of the function is 0 is less than or equal to y, which is less than or equal to 16, or y equals 20. Right, you see that? It could be up to 8 pounds. 20, 22, 35 are our prices. So we have 20, 22, or 35. So it could go up to, it'd be 16 because it says $8 per pound up to 2 pounds. So the highest it could be would be 2 pounds, which 2 times 8 is 16. That's how they get that 16. This represents the possible cost of coffee beans, the cost of it. Okay, one more set builder and interval notation. How do we write this? That's where we're headed now. Sets of numbers like the domain and range of a function can be described by using various notations. Set builder notation, interval notation, and algebraic notation are all the concise ways of writing a set of values. Consider the set of values represented by the graph. In blank, that blank is algebraic notation. Sets are described using algebraic expressions. For example, x is less than 2. Okay, that would explain this sentence right here. Writing it like that is algebraic notation. If we want to use set builder notation, it's similar to algebraic notation, but braces indicate the set. The symbol straight up and down is read as such that, and the symbol that looks like an E is read an element of. For example, there are brackets, squiggly brackets, x, such as x is less than 2. Okay, they might write it like that. In interval notation, sets are described using endpoints with parentheses or brackets. A parentheses indicates that an endpoint is not included in the interval. A bracket indicates that it is. So basically the difference is the parentheses represent less than or greater than, and the brackets represent less than or equal to or greater than or equal to. Four more boxes, we got this. Write the domain and the range. Write the domain and range of the graph in set builder and interval notation. The graph will extend to include all x values. The domain is all real numbers. Okay, so it tells us the domain is all real numbers. The graph will extend to include all x values because that graph is going to keep going on and on and on. Okay, so the way that we're going to write this with set builder notation is to say that x, such that x is an element of, and then use the all real number sign. Use that capital R with the 2 lines. I can't really tell there's 2 lines. Let me fix that. Now this is going to be something we're just going to have to get used to. You also could say with interval notation, it goes from -infinity to positive infinity. Anything at all works. Okay. And we can't ever actually get to infinity, so we have to use parentheses around that when we use interval notation. The range. The least y value for this function is -6. So we are going to write this with set builder notation as y and then that line, and then y is greater than or equal to 6. Now the interval notation, notice it has a bracket at -6, that because that's where the minimum value is. And then it goes up from there to infinity. But you can't ever technically get to infinity, so that's why that one is a parentheses. Okay, let's practice some more. This is going to take some practice. We'll get used to it. Use your notes. You get the hang of it. It says, what is the domain and the range for this function using set builder notation? Okay, so the x values, it goes to the left and the right. It continues on forever in those directions. So it's got to be one that has all real numbers. Oh, they did both notations. So we got to be able to use either one. So it could be that one. That one's good. That one's okay. That one is okay. This one is not okay. It's got to go from -infinity to infinity. That one is not right. That one is okay on the domain. So now let's check the range. The range, the y values, it starts at 0. If we're looking at the y-axis, it starts at 0 and it goes down from there. So y should be less than or equal to 0. So that one's good. -infinity to 0, that one's okay, right? It's -infinity is clear down here up to 0, that's it. You always put the smallest one first and then the bigger one in that order. This one says it's all real numbers, so that one is not right. What about this one? I skipped it. Oh, does it include 0 or not include 0? I didn't catch that that one had a parentheses. So it's not that one, right? We need a bracket on 0. We need a bracket on 0. So this one is out. Our two that would work, it says select all the correct ways, would be A and C. Okay, take a minute to look those over and see if you can distinguish why that was the case. And then we're going to try to write some domain and range in set builder and interval notation. So first, let's do the domain and range and set builder notation. The domain, I'm going to use D for domain. I'm going to put a squiggly bracket, right? Let's practice writing this. We haven't done this yet. X, straight up and down line, a squiggly bracket. And then I'm going to do the range is going to be the y values. I'm going to do y, straight up and down line, squiggly bracket. Okay, but we got to fill this in. What is the domain? It's going left, it's going right. There's no end to it. It's going to keep going. So we're going to say X is an element of all real numbers. The range, it doesn't go up higher than 3, and it's everything underneath that. So Y is less than or equal to 3. Okay, so when I write that with interval notation, the domain is -infinity to infinity. The range is going to go from -infinity up to 3, and it includes 3, so it gets a closed bracket on it, right? Okay, so we need to notice that less than or equal to is going to go from -infinity to whatever number and then have a closed bracket. Greater than or equal to is going to go from whatever number with a closed bracket, because it's or equal to infinity. And that'll be a parentheses. If it is less than, then it's not going to include it. That's going to go from -infinity to the number, but it'll be a parenthesis on it, not a bracket. And if it's greater than, it's going to go from the number to infinity. Both of them parentheses, no brackets, because it doesn't include it. Okay, so that's an important note to have written down. That'd help on a quiz or a test. So write that down. Let's do this one. Domain. I'm going to get it set up again. I'm going to do my squiggly bracket, X in a line. that says such as, and then the range with the squiggly bracket, y in a line and a squiggly bracket. Let's look at this. The domain of this one, it goes left and right all the way. It goes up and down all the way. So both of these are that capital R. Y is an element of all real numbers. So when we go to write the domain and the range in interval notation, they are both negative infinity to infinity with parentheses because you can't ever technically get to infinity. All right, one more chance to practice it. Pause it if you need to finish writing all that down. Let's look at example 7 here. It says write the domain and the range of the graph in set builder notation and interval notation again. The domain is all real numbers. Oh. All real numbers less than -1. I see, because it started at -1, not or equal to, just less than -1, or there's a closed circle greater than or equal to or equal to 0, because it starts here and then it goes to the right. So when we write that, it's broke apart. It can go from -1 to negative infinity, but they're not going to write it that way. They're going to write negative infinity to -1. And that one has an open circle. You see the open circle? Open circle means it's a parenthesis there. This is x is less than -1, not or equal to, less than, which is why it has a parenthesis, or x is greater than or equal to 0. So that's why it has a bracket on 0, the infinity sign, and it's never a bracket on infinity. It's always a parenthesis. The range is all real numbers. Let's see, the range starts at -1 and it goes less. So less than, not or equal to, it's an open circle, less than -1, or starting at 2 and going up, greater than or equal to 2. So when we write that, y is less than -1, or y is greater than or equal to 2. Let me get the squiggly brackets on there to end it. And then here we have parentheses, it doesn't include it. Also joined with 2. Okay, so notice they use this little u that's just showing that that's joined together. There's 2 different ones. We may not get this the first day. This might take us a little bit of practice, but I know that you guys can do it. We'll get the hang of it. I'll help you. Don't be too hard on yourselves. This is the first lesson. There's a lot to this lesson though. Select all the correct ways of stating the domain and range for the function. Okay, so I look at this. I see that x, it stops. You see that? It doesn't include anything between -1 and 1, but everything else is good. It goes left and right from there. Okay, so it has this little place where it's broke apart. So it includes everything less than or equal to -1, everything greater than or equal to 1. Not everything. This says everything. This says all real numbers. That's gone. It's not that one. That says x is less than or equal to 1. That's not true. That one's gone. Negative infinity to infinity, that one's gone. This one goes from negative infinity to -1. That's good. And then also it has the u, also includes 1 to infinity. So that one's okay. This one is gone. It's not all real numbers. This one's okay. Less than or equal to -1, greater than or equal to 1. And then the range goes all the way up and all the way down. It's everything. So that one was gone already. This one's okay. D and F are both still okay. This is all real numbers. This says -infinity to infinity. That was a tricky one. State the domain and range and set builder and interval notation for this graph. All right, set builder. That's the squiggly brackets for the domain. X, the line, squiggly bracket to end it. The range, squiggly bracket, Y, a line, squiggly bracket. Let's fill that in. Oh, I needed more room because there's 2 branches. This one goes, X is less than -1 or greater than +1, greater than or equal to. It's got a closed circle. Open circle is less than or greater than, closed circle is or equal to's. So it has the lines underneath it. Okay, so this one would be X is greater than or equal to 1. The range goes from 1 and down, so Y is less than 1, or Y is greater than, come down here to -1, or Y is greater than or equal to -1. So with interval notation, we're going to have from -infinity to -1 with a parentheses, not a bracket because it's an open circle, joined with, oh, this one's a bracket. It starts at 1 and it goes to infinity. That's the domain. The range. The range goes from -infinity up to 1, but it doesn't include it, joined with, and then it starts over here at -1 with a bracket and goes up to infinity. All right, thanks guys. We'll practice it. I'll answer questions. We'll see what you're understanding, what you're not, and we'll go from there.